Today, myself, Fahad Amri, and my teammate Salam Bilharith, we will be talking about Lua programming language. And let's start. So, we will start by having an overview. Then we will see how to install the Lua. We will then go to the data and the control abstraction, and then we will end with seeing the programming paradigms. Let's start with the overview. So Lua was created in 1993 in Brazil. So Lua itself means moon in Portuguese. So its main goal was to be lightweight and to be embedded in systems. So it had to be quick and relatively small in size. And it should be highly customizable. For the features, it's lightweight, high-level, fast scripting language. It supports procedural and functional programming paradigms, so it's not just functional or let's say like object-oriented. It's multiple paradigms. It's popular in game development, and it offers powerful features like first-class functions and table-based structures. Let's see how to install it. For Windows, just follow the link, then download an interpreter, also the link shown, and then just go to the command prompt and write Lua -v to check the version. If you see a version, it means that the download was successful. For Linux, it's even more simple. Just open the terminal and write the sudo command shown in front of you. Then check for the version, like Windows. If you see a version, then it's been successful. Same with Mac. Now we will go to data and the control abstractions. So to see these in working in the code, here is the code. We will start by talking about the basic contents, like the data abstraction, then we will go for the control abstractions. For the data abstractions, we first initialize some variables. We see how to convert types. We then print the types. Here you see that table is mentioned twice, but we create a list and we create a dictionary. So the reason for that is because Lua sees them all as table. And if you notice here, I hope this is understandable, it's one indexed. So it's not zero indexed, it starts from one. And as you can see, we print the first object, which is apple. And as you can see here, we see an apple. Also, let's just run it. So I see it's working. Now, we then print the student's name, the math score. Here we also do it recursively. We do the countdown recursively. As you can see, because it's recursive, it prints after. So we just print it recursively. And then we initialize the grade again and to see how the control abstraction section work. Here, for the abstraction section, we first do the if-else, which works perfectly. We then go for a for loop, a while loop, and then we do a repeat, which is similar to the loops. The next we will see functions before we go as part of the advanced content, but I will leave this for my teammate while he explains the PowerPoint. So going back to the PowerPoint, you see the data abstraction here, variables, the conversion, the arrays, and how they are done in Lua. Also, we saw the control abstraction, which is doing the if-else, for loop, while loop, repeat, pass-by function, which those two will be seen in my teammate's part, hopefully. So yeah, I'll leave you with him now. Thank you.
Assalamu alaikum. My name is Salam Bilharith and I will continue from here. So first we will discuss passing by value. So when you pass a number to a function, Lua gives the function its own copy that you cannot change the original. So here we cannot change n, and we are printing the value of add1, which here we gave the input as 10 to this function, and we called it to be printed here as 11. So basically we're passing a value to the function, and we're doing some computation, but we are not changing the value, the original value in. Second thing is passing by reference. So tables are passed by reference. Functions see and can change the same table you passed in. So we created here before the student here, which is a table that we will use as an input to our function. So we created a student with the name, and we are trying to change his name here using this function. So the function update student table defines update name that takes student table as its input. And here we are accessing or mutating the name from the table itself, and we're setting it to updated name. And we are calling the function here, which is update name student. Yeah. And we are trying to print the updated version. So now the student table itself has been updated. It has now the name as updated name. So when we print it, we get here updated name. Next is we are discussing the object-oriented programming paradigm. So Lua uses tables and meta tables to mimic the classes and inheritance. So here, person with this curly brackets, empty ones. This creates the base table to hold our class methods. Next is this line. It basically tells Lua, if you look up a missing key on an instance, just check person next. And this is our function that is creating the class. So it's basically a constructor. If you dig deep in the constructor itself, we will see this line, which basically makes a fresh object whose meta table points to a person. Second thing is just basically storing fields, and we are returning self, which hands back the new object. Here we have the function person greet, which is a method that prints a greeting using the object's name and age. So here we are saying hello, I am self.name, age self.age. Yes, so here, hello, I'm Bob, my age is 20, which is one of the objects we created. Next is inherit values by meta tables. So in this line, we have a new table whose fallback is person. So it inherits person methods. It takes basically inheriting the methods of person. So, which is yeah. Next thing is student.index equals student that looks up a missing method in students itself. And finally, we have to call the person's constructor to set a name for him and age. So this basically sets a name and age and ID, of course, to the person or to the student. And finally, we are printing the student ID, and we are fetching his ID. So we have now, yeah. So as we can see here, he did not define name and age because these two are inherited from the function here. So my student ID is S123. That's also an object you created. So you can see that's the object you created. His name is Bob. He's 20 years old and he has this ID. So if you call greet and display ID, greet is a function that is from here, and display ID is defined here. So yeah, now we move to the functional programming concepts. So a higher order function is basically functions that can accept other functions or return new ones, capturing like variables from their defining scope. So if we dig deep here, we have operate on numbers, which defines a function that takes two numbers and a function f, func f, this. And it returns, it just calls func on a and b. So if you have like multiplying here and we have 3 and 4, it just gonna call this function, which is multiply here. It will evaluate it. This is called lazy evaluation. So it will replace here the name of the function as multiply, then it will call it on its variables. So yeah. So here we are passing an anonymous adder function, as we said here. This is a 5 and b equals to 3, and this is our function. It's function xy, and it returns this. We basically defined a new function here, which is also a feature of Lua. Here we can define it outside and call it whatever, or we can just write it as is in here. Then we are printing sum using higher order function as results, which shows here. No, yeah, which shows here, 8. So 5 plus 3 is 8. Or we can use the other way, as I said, that we define the function outside, then we pass it as a parameter to operate numbers. Okay, but we have another example of this close. So close here, this function takes one variable as an outer, then in the print it takes the other value, which is other variable, which is y here. So here it will print out 2 multiplied by 5 equals 10. That's it. So we explained everything here. Pass by value function, reference by table function, and we introduced programming paradigms. So Lua supports lots of actually paradigms, which is object-oriented, functional programming, meta-programming, data-driven programming, cooperative multi-threading, but the ones we discussed and we could discuss, no, we discussed already in the code of the first two, which is the OOP and functional programming. And the slides here is just basically everything I said in the in the code explanation we did. So we have a pop-up quiz here. The first question is, what data types does Lua use to represent areas and objects? Second thing is, what is the output of type nil in Lua? Third thing is, which statement creates a local variable in Lua? Fourth thing is, what is a keyword? For loops that repeat until a condition is true. And the last question is, which of the following can be used to simulate a class in Lua? So you can stop the video now and try to answer these questions. Now we'll provide the solution in the next slide. Okay, I hope you have solved the questions. So these are the solutions. And that's it. Thank you so much for listening to our presentation. These are the references if you want to get more knowledgeable in the Lua programming itself. And thank you.